Okay, guys. Now, big one now, binomial. I've already shot this once before. I'm bloody annoyed, so let's see if we can get it right this time. Okay, so what's binomial distribution? It's a model that we can use to describe things that happen in the real world, and we can use it whether these four criteria are in play. If these four criteria are fulfilled, we can do this. Criteria number one: we need to know how many trials there are going to be. Yeah. What do we mean by trials? Let's take an example. Suppose you do an experiment where you're going to toss a coin 30 times. That's 30 trials. Okay, so we need to know that we've got trials. We need to know how many we've been doing. There's two possible outcomes to the trials. Generally, success or failure. So, like if you toss a coin and you decide heads is success, tails is failure. It can be any two things that are mutually exclusive. Has to be two, can't be three, can't be five, can't be 10. But it's got to be two things that are mutually exclusive, which, if you remember, means that either one can happen or the other, and there's got to be two of them. Third one says probability of any success is constant. Basically, probability doesn't change. Going back to that tossing a coin thing, you toss a coin, the probability of its heads is 0.5, as long as it's a fair coin, and it will always be 0.5. You toss the coin a million times, it's still 0.5 to get ahead. And finally, that all the trials are independent. So basically, the result of one trial doesn't affect the other. Um, so you toss a coin again, the coin doesn't have a memory. It doesn't remember it's had a head last time, it should be a tail next time to keep things even. It just does what it does without. There's no kind of like it doesn't affect it. You toss a coin a 15th time, the 14 tosses before it hasn't affected what's going on. So they're independent. Now, what I'm going to do is look at the kind of notation on the binomial distribution first of all, then we'll take an actual question. Okay? Okay, so here we have this wonderful notation here. Um, what does it mean? The x means the variable. The tilde means can be approximated by or can be modeled by. The b means it's binomial distribution, so kind of key word to have there. N is the number of trials, it's not the number of events. That's why I had to bloody reshoot the damn thing. So basically, how many times are you going to do the thing, and P is probability. On the right side of things that are not on the syllabus this year, I'm not sure they're on the syllabus next year either, but they're there. X bar is N times P, and X bar just means the mean, so the average result. And sigma squared variance is NPQ. I'm pretty sure that's the right way around, but if it's not, I don't care because you don't need to know. I know what, the mean is definitely right. I think it could be the variance or standard deviation. Nobody cares. What's on the left is really important though. That's the actual formula we're going to be using throughout. And that says the probability of getting R successful events in N trials. So basically, if it was tossing a coin and heads is your successful event, and you say, okay, I'm going to toss it 6 times, what's the chance of me getting, say, 3 heads? N would be 6, R would be 3. And that's, if you have to think about the probability as well, it's P to the power R, 1 minus P, N minus R. You can read, I'm not going to read you that formula. Now, what I will say is right now it probably makes very, very little sense, and I understand that. That's why we're going to take an example. So, if I was you, like, if you've got pen and paper, write down that formula and see how I'm going to apply it on the very next slide. It's not really a slide, the very next piece of paper. Okay? Alright, right here. What do we have now? Well, we've got a question here. First of all, we need to decide whether it is binomial or not, and that's something you've got to test each time. So we've got 4 conditions. Let's read the question. The chance of a traffic light being green is 0.8. What is the chance of 4 traffic lights out of 5 being green? So what are the tests? First of all, we need to know how many trials we've got. 5. We've got 5 traffic lights, and that's cool. We're going to go through 5 of them. That's the number of trials. The probability is constant, 0.8 for every single one. You need to have a... They need to be independent. That's definitely a thing you need to watch out for. And to be fair, in real life, they're probably not independent. Anyone's ever been in a car knows you hit one red light and you get about 15 other ones straight after it. But we're going to just pretend for the sake of this question that it is independent. And there's one other thing you need to know, which is slipping my mind at the moment. You need to prove that... Let's have a quick look. This is what we call competence right here. No, that was from last time. There's 2 possible outcomes, yeah? And now, to be fair, I've been kind of sly about that. Instead of going red, amber, green, I've gone green or not green, okay? So, you've got 2 outcomes there. If I had gone red, amber, green, this wouldn't be binomial anymore. So, we do this. Solution as it is below. So, we start by writing it out as a binomial. X is binomial with 5 outcomes. Sorry, 5... What am I saying? 5 trials and probability 0.8. We want 4 out of 5. So we put in our bracket on the left-hand side, 5 choose 4, and that is literally the binomial 5 choose 4, nothing exciting there. You remember that from your kind of expansional brackets from way back in core, and if you can't remember how to do it, it's just 5C4, and I've shown you how to do that several times, and if you can't do that, please just drop me a message and I'll show you how to do that. 0.8 to the power of 4, why? The probability of a success is 0.8, we want 4 of them. It's not 0.8 times 4, we've discussed this at length. It's 0.8 times 0.8 times 0.8 times 0.8. Then you've got 0.1, sorry, 0.2 to the power of 1, because you want one time you want it to be read. You multiply those together and get the answer, and that's that. If you've got any further questions on this, let me know. But that should cover you, and I think 5.5 minutes is long enough for a movie, a video, or whatever. Bye.